we need the Genymotion IP address, and today we're gonna start with our Diva application, and we're gonna look for insecure logging. You can see we're gonna follow the OWASP top 10, and with OWASP top 10 we're gonna follow the insecure logging attack. What is that? So we need to connect this IP address with the server. So I'm gonna check the IP address on my device phone, which is 192.168.0.106. So over here we have a device, and we're gonna use Diva over here. So there are 13 challenges. We're gonna try one by one all the things over here. So first of all, let's try to connect with the server. So I'm gonna use ADB connect and the IP address. So ADB Android debug bridge, and then we make a connection with the target, which works on the port number 5037, and on the server side it will connect on the your 5555. So we can see that the device has been connected. So we're gonna write ADB shell. So now we can see that we are on the server side on the mobile device. And what we're gonna look for, we're gonna look for the entire architecture, that where should be the relevant data could be. So we can see there is you can see the act, cache directory, configuration directory, your data directory, your dev directory, which is just like your Linux server. This is just like your replica of your Linux. So you can see amount, processor, property contents, root, has been SD card. If you have an external card, you can see over here. So lots of things are given. And one more thing, you have to check what are the applications are running. So I think PS AUX will not work. The PS will work. PS, which is your process. And over here, I can see all the applications are running in the proper manner. And as I have mentioned, that initialization is the first stage where all the application works. We can see init and the other application which is working for the mechanism of the core. So over here, you can see some of the applications are installed, system applications. And system applications, you can simply see the username also, which is your chaka asim.diva, and your process ID plus the UID, the user identification numbers. So we're gonna see that there is a jaka.asim.diva. We can simply copy this one and let's jump over there. Okay, so first of all, it was a process. We're gonna go to the CD data directory. Why CD data directory? Because CD data directory contains all the databases data on the server side. So over here we can see app, applications, backup, bug report. You can say Delphi cache files, data. On the data directory, all the applications are installed. You have to understand the architecture of the mobile applications. So there's a don't panic. Yeah, these are the normal default parts. So let's move to the data directory. In the data directory, you will see all the applications, and this all the applications has been installed, like your calculator, calendar, camera, content, custom locations, keychain. But our main focus would be around our diva.jaka file. So let's see Jaka. So over here you can see there's a cache file, there's a database file, and some installed libraries, dependencies. So, and the user identification number. So each and every user has an identification, just like see over here PS. See this one, U0A62. See, U0A62. You have to identify with the process ID number or the process name. This is the ID number with. So our main concern is how we're gonna read about all the things one by one. We can see this is a cache, database, and lib. You can see, you can use any of the directory. This is cache is the directory. See, let's see the cache directory. What could be over there? There could be simply case history files, and something will be blank. Let's do databases. Databases contain all the architectures. You can see devotes.db, your devotes.db general. It's a database libraries that can be used for entire subscription part. Let's go back and let's use lib. We can see the libraries over here, which has only one library, which is your shared object. So our major concern is to read about all the programs and the architecture, or we can see the decompilation part that we have done yesterday. So it was on mobile directory, I guess. Yes, we can see over here the deep over here the diva.apk file was a compiled file, so we have to decompile it. And there are many ways that we can use. For example, we can use Gettext, we can use unzip, we can use apk tool, and we can see all the things one by one over here. So our main objective would be how we can understand the core mechanism of our Diva application. So Diva, damn secure and vulnerable application, you can see is an app initially designed to be secure. The aim of this app is to teach developers, QA and security professionals flow that are generally present in the app due to poor or insecure coding practice. So if you are reading this and want to either learn app application testing part, secure coding, and sincerely hope for the Diva solves your purpose. So you can see there are around 11 machines, 11 challenges you can see over here one by one. So we're going to look for the first one, which is your insecure logging. Insecure logging, find out what is being logged and where and how and the vulnerable code. Insecure logging occurs when the developer initially logs sensitive information such as credentials and session IDs, financial data, and etc. Initially sensitive information. So what could be the possibilities over here? Let's see according to the OWASP top 10. So we have top 10 critical mobile application part, which is your improper platform uses. This category covers misuse of the platform features or failure to the use you can say use platform security control. This might be include your Android intent. So this is a keychain. You can see a touchpad, a keychain of some of the security control. Insecure data storage. It's all about the database management. Insecure communication, or we can say insecure cryptography. I will take these two of it. It covers poor handshaking, incorrect SSL version, weak negotiation, clear text communication, and sensitive assets. So I will talk about this one. Clear text communication and sensitive assets. This category captures notion of authenticity, the end user, and the bad session management. Or you can say insufficient cryptography. The code applies cryptography to a sensitive information assets whenever the cryptography is insufficient in the way some that anything and everything related to TLS and SSL goes to M3. And if the application fails to use cryptography at all when it should, that probably belongs to M2. This category is for the issue where cryptography was attempted but not done correctly. So over here, it's all about the clear text communication password. For example, see this one. Insecure logging part is the important thing. Android application may store some data as logs. It's all about log analysis. Logs are stored in central places and every Android application can access those logs. But in the latest Android version, permission for accessing the logs are changed. Because you have to give the authority or the permissions. So over here, insecure logging. Many developers log information to the Android logs, sometimes sensitive data as well. To inspect the Android and emulator log files, you have to run the following command: adb shell ps grep diva. So what exactly this means? Over here, the main objective of adb shell to get the process ID, which is running as diva. Let's see. The application is running over there. Adb shell ps process. We can see all the application which is running as the user on the specific server one by one. And the main objective that we can look is jaka.async diva. So we can use a grep command to fetch the file. So over here, the main objective of this exercise is to identify the weak encryption standards or the clear text submissions between the two clients. And the most important thing is to understand how the application works. You can see ADB logcat grab process ID of the application. What is the use of ADB logcat first of all? ADB logcat. The command will try to log the following for you to see the output of the application logging in the console. Okay. So we can analyze the logs. Over here, it's all about log analysis of the applications which can be affected over there. In this lab, run exploit me mobile and execute a transfer of funds with the applications or just run the application in general. Observe what is passed within the log files and what is executed in different screen in the applications itself. Visit the screen and observe the logcat output. So let's see the basic concept of logcat. ADB logcat. So logcat over here, it will simply make some logs and trace all the packets on the server side. It's all about clear text or clear text submission thing. So what I'm going to do over here, I'm going to look, let's take an example of some of the basic applications. So let's see the example of dialer. And the process ID, which is your 1096, or you can simply write the name. ADB logcat grab so over here it's on the login monitoring part, and let's see what we can do. Dialer, it's like your phone, cell phone. And what we can see, somehow the logs has been generated in the backend process. You can see over here, no contact phone services contacts dialer. It's all about to analyze the clear text submissions. Clear text submission is an important part over here. And the most important thing is to understand the read about the source code on the Gettext. So the very first thing is your log activity, insecure logging. So over here, see the public code, the Java code. The main important is the Java code. Over here, we need to understand what the exactly code means over here. So public void, they have given a normal class, and over here you can see they are using a catch function. A catch function is saying log into diva log error while processing the transaction with the card. cc.text.getText. So the main function, the get text in the Java. If you get the information of get text, the get text provides a standard mechanism for extracting the text from the VLS logs. Messages get logs. Messages are identified by their logs, and it be qualified by a subsystem name. The basic format of the string objects written in the getText method is to message the body or the request message. So it clicks to fetch the file. What is the getText and the setText in the Java file? The getText method returns a string. See, it will fetch the string from the client's client side, while the setText receive a string. So you can write it like label 1, setText, name, and getText. Receive a string and return a string. So over here, the getText which is given here is to basically fetch the file from the client side. But we're gonna see if if the client is simply putting his credentials on the application tab, what will happen over there? So my major concern would be I'm going to use the application over here, and over here I'm going to use the grep command, and in the grep command we're going to use jaka debugger. Okay, so we have put a MITM. You can say manage the manager tag. You can say, or it's a you can see log analysis. So over here I will go to the debug part, and the first one. So find out what it will be logged, where and how, and vulnerable code. Okay, so enter your credit card number. So let's see, 1234. Okay, total 16 digit words. Let's enter. An error occupied while trying to later. But the most important thing, if you see on the server side, on the application part, it still haven't get anything. Why? We have to process the process ID number. As per the data, look over here. The process ID number. The process ID number which is given over here is your 1554. Let's see this one. Let's use clear tag. What was that? 1544. See, you can see all the logs over here, which is on the client side, and we can see it's on the plain text. Because of the poor code, the data should not be stored or written in the value on the clear log text. It can be disaster, or it could be a critical vulnerability and perform an MITM attack from the cell phones. There are various ways that we can protect this one. Because of the get text, it's going to be fetching the data or return the data from the log analysis part. And you can see that while processing the data, we can see the error while processing transaction with the credit card. An error occurred, please try again later. Some other techniques can be performed over here, some other ways that we can use it here, one by one, all the things will be necessary. So our major concern would be how we can look for each and everything. If you check for the insecure logging vulnerability in the hacker, you will see lots of things. Insecure logging, hacker one. Insecure data storage. $140. It's an insecure data storage over here. Insecure logging. See over here, they have given insecure storage or insensitive information, which is one of 5th of December 2019. The tester discovered the Razer Pay Android application was storing user data locally on the phone in the clear text. An adversary would need to access the phone to obtain this information. The application was patched to avoid storing the information in the version 2.0. So they didn't give any information further. They simply given that it's a bug, it's a dollar of 400, and it was insecure in the storage data, which in Razer app. Or you can simply look over here also. Insecure local data storage application stores data using a binary split database. An Android app and an Android provides several options for developer to save persistent applications data. The local DB should store the data depending on whether the data should be a private or application or inaccessible to the application and user. In many cases, sensible data always have to be encrypted to avoid privacy violations. LinkedIn app keeps your user data in SQL database. See, LinkedIn, if you are using LinkedIn application. The OWASP top 10 insecure data storage or insecure data, or you can see the SQLite database. There are many ways that we can use it for mobile application store. Insecure logging, you can see M2. So let's see this one. So they have given some applications just like insecure logging, OWASP top 10, M2. Or it was on Razor app, same Razor app. All you have to do is to figure out the vulnerabilities which can be present over there one by one. The main objective when you are simply doing a mobile application testing, you should know about each and everything on the server side. There are many kinds of vulnerability that can be used over here. According to the OWASP top 10, OWASP top 10 critical vulnerabilities are the major functionality that can be used for your data and manipulations and the security issues. There are lots of kinds of vulnerabilities due to insecure communication, but the most important thing is to understand how it works and your insecure communication also. It covers poor handshaking, insecure SSL version, keep clear text communication, or you can see the insecure data storage also, which is data leakage. This newly categorized of combination of M2 M4 for mobile top 10 2014. This covers insecure data storage and initial data leakage that can be used in varieties of things. But the most important part is to understand how the core mechanism and the mobile application works over here. So whenever the output is going, it should be on the proper manner. Insecure logging occurs. Developers initially log sensitive information such as credentials, session IDs, and financial details, which is stored on the server side. All the things over here is interconnected. For example, if you look for the hard coding issue, it's a major part. Most of the API applications are not aware about that they have stored the password or API key in a proper clear text submission. And this one, I will say, client code quality, hard coded issue. Why I'm going to say this one? Because this was a security decision was untrusted input on the leisure use categories. This would be a catch all the code level implementation problems in the mobile client. That's distinct from the server side coding mistake. It would capture the things like buffer overflow, format string, vulnerabilities and various code level mistakes where the solution is to rewrite some code then running on the mobile device. So there are lots of further things that can be happen over there. The client code quality. Why I'm saying the client code quality? See over here. The insecure logging was to simply get all the database or file the log files on the server side. But the most important thing is to understand how the core mechanism works. For example, you can see hard-coded issue. Hard coding issue is one of the major attacks or major possibilities that attackers simply find some clear text passwords on the mobile application backend source. And there are lots of further things that can be happen. For example, sometimes developer make a mistake in the source code of Android applications. This explicitly defines a constant value. If any of the confidential data is hard-coded in the source code, then it has also a security issue. The hard-coded data might be password, access token, or authentication string. See, the hard coding issue is a vulnerability that from the developer writing and credentials of sensitive information in the source code. Attacker can download the APK file, then use the decompiler tool, uses APK tool, Gettext to decompile and disassemble the application. Then attacker can search for the credentials over there. For example, over here, we're going to use our Gettext. And in the Gettext, you can see hard-coded issue, first of all. Some of the application I was talking about, the hard-coded issue is just like your API tools and API sensitive informations. For example, you can see, again, they have a value which is given vendor secret key on the clear text password. As per the data can be fetched by easily over there without any interruption or anything, because the data can be possibility filed. Vendor secret key. Let's try over here. Find out what is hard-coded and where. Developers sometimes will hard-code sensitive information for easy because of the poor code, and the vendor code was vendor secret key. Access granted. See you on the site. Because of the poor log, we can simply see all the things. You can see they have catching the hard-coded issue, process ID. The hard-coded issue was arise when the developer might store sensitive information on the backend of the source, and they are not aware about that they have mitigate or not. The most important part is to mitigate the services one by one to perform a security reason over there. For example, if you search for the hard-coded issue, API key, see, GitHub repository, insecure data storage, API key, app loving key, which is your tutor, and you can see over here mobile app, hard-coded education in mobile applications. These are some sensitive informations. Insecure data storage and API key permission in Android app. Most often developers for easy for use leave API keys and some sensitive keys token as hard-coded string, which isn't really a good idea, as it can result in leak of sensitive information, getting it wrong-handed, and indeed can result in the data theft, tampering with how the application deal with the data. See, I found a bunch of API keys. You can see over here. To check the API key leak sensitive information is not. Proof of concept screenshot has been attached as a proof of concept, you can see, but they didn't give anything because it could be sensitive information. And it's all about the reputation of the company. And it was on your Zelly. API key hardcode and GitHub repo. Hardcode recognition in Android applications. It was on 2017. See this one. It was on Zomato. After decompiling the Zomato app, I found basic HTTP credentials in the app. The sort of happened in an accident since I was looking for a new endpoint of the API intent of the looking for the credentials. After finding the credentials, I didn't know what to do with the since our domain belongs to a 50503. See, it's all about decompilation part. All you have to do is to decompile the files and check for the sensitive data that can be easily fetched on the server side, and that can be monitored with the help of tools and Gettext applications, one by one. So All you can do is decompile the files, or you can look for all the details one by one. It's all about the, you can see the resources or the android.xml file. You will get all the things you want in your upcoming sessions over here. The most important thing is to understand how the application works in the design flow and the original form of the data that can be reading in the later upcoming session. All the things will be belong to your OWASP top 10 and your credentials activity. Remember one thing, M7, M5, M3, what are the things over here is given a proper validation of the information. Reverse engineering in this category includes analyzing of the final code or binary to determine its source code, libraries, algorithms, and other assets. Software such as IDA Pro, Hopper, O tools, and other binary inspection tools can attack us inside. Extraneous functionality. See, there are lots of things over here in our upcoming sessions. And the most important part is your today how we can use all the ADB tools and the issue that arise over here to understand the core mechanism of the vulnerability. You can see I have given some of the links that you can learn over here more things. For example, let's see this one. So over here I have pasted some, you can say some examples over here. There are different ways to check the hardcoded values in the Android application, but most of the popular method is decompile the application file and look for the previous source code. Before directly jumping to the decompilation tool, let's have a few discuss. They have given the class.dex file. Right click, extract here, unzip the file. You will get all the files you need. Now the content will be in the directory of jacket.xml files. What you can do, you can simply use all the dex2jar file to examine the source code. As we are using Gettext. APK is a file packaging format and could be unzipped. Java get compiled to deal with bytecode when you build an application. Dex2jar convert the class.dex file and .jar file. Gettext.u Java decompiler which can be used for decompile or .jar files that show the procedures contained in the file. So it's all about the informations of the source code read. You can use any of the files over here. Or you can see there's some mediums which I given that can be also useful. Diva series on hardcoded issue. See. You can see it's a vulnerability that developers writing any credentials or sensitive information in their source code. Attacker can download, they use the decompiler tools, and you can see all the things is one by one given. You can read the reference if you want. The Android applications of Diva. So this was all in your today's session, insecure logging and the hard-coded issue.